So let's try to talk about reflecting quadratics. So reflecting quadratics happens when we reflect it across the x-axis or when we reflect it across the y-axis. And it's another type of transformation that we're going to be working with. We're going to look at it specifically for the parabolas, which are also known as quadratics, which is the picture that's drawn here on the screen. But to illustrate one of the features, I need to use a different graph so that you can really see what's happening here. So we're going to start by graphing, and here again is our parent function. F of x equals x squared is shown on the grid. Well, what's going to happen if we put a negative in front of that function? So we go to our calculator, we go to y equals, and we type in negative, parentheses, x squared, and we look at the picture. And what happened? We can draw the picture in, but what happened from our original to now our blue screen here? It reflected. And oftentimes what people say is they say it flipped, which the word for flip, the mathematical word for flip is really reflected. And we reflected over the x-axis. And the nice thing is that you did type this into your calculator so you could look at the point on your screen, but the pattern of the graph didn't change. So if you don't have a graphing calculator, what happens is instead of going one space to the right and one up, our point's going to be one space to the right and one down. Instead of going two spaces to the right and four up, we're going to go two spaces to the right and four down. Three spaces to the left and nine up, or three spaces to the left and nine down. And that pattern continues on the other side. One space to the left, instead of going up one, we go down one. And two spaces to the left, but now we're going to go down four. And three spaces to the left, we're going to go down nine. And I kind of left out the fact that our vertex remains the same. But with that graphing calculator, it really is helpful to be able to get that picture. But now, what we want to look at is well, what about y equals when the negative is inside the parentheses squared? So we can come back to our calculator screen. And we'll graph this next one. Again, the negative is on the inside of the parentheses. Well, what do you notice this time? And let's take a look at our points here. We have points like negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. If you go back and look at the picture, we have 0, 0, negative 1, 1, negative 2, 4, positive 1, 1, positive 2, 4. What transformation happened here? Well, based on the picture, this is what we have on our screen, roughly. We can't tell what happened. So since we can't tell with this picture, let's try to look at this graph here, which is the parent function for the square root of x. And there's the basic function. And as we look at the first one, we're going to graph negative the square root of x. So let's go back to our y equals. And it's going to be negative the square root of x. We kind of have an idea of what we think this is going to look like. And we graph. And what we said in 1a is that our graph flipped over the x-axis. Well, it looks like the same thing happened here. And in fact, if you need to, you can go to the table here. I don't have very good numbers on my screen, but I've got a couple. 0, 0 is a good one for us to graph. 1, 1 is a good one for us to graph. And you can scroll through yours as well. But we do have, we've got 0, 0, 1, negative 1, 4, negative 2, and as you scroll through your screen, it's actually 9, negative 3. And this is our y equals negative the square root of x. But like I said, we couldn't tell what happened when the negative was inside the function on our first graph. So let's see if we can figure out what happens now when the negative's on the inside of the function here. So we're going to do second square root of negative x inside the function, and we graph it. And there's the picture. And we can look at our points here on our table, which I won't spend that much time doing. So we get 0, 0. We have negative 1, 1. We have negative 4, 2. And we have negative 9, 3. What happens here, and I didn't write down A, I'm just now seeing, what happens when we have a negative inside the function? How does that really work for us? And what it did is it flipped our graph, which again, the word for flip is reflect, over the y-axis. Before I move back to 1b, let's fill in that green idea, y equals negative square root of x. This is what we were just doing, y equals the square root of negative x. But what happened when we graphed the green one is that we flipped, again the word is reflected, over the x-axis. Oh, and I erased too much. Over, there we go, the y-axis. So we can go back here to 1b. Now that we've seen it, we cannot tell, but the graph is flipped over the y-axis. It just doesn't show up in our picture. But what happens is that this point here landed here, and vice versa. This point here landed here, and vice versa. This point here landed on the other side of the y-axis, and vice versa. You guys can't see it in that picture. So let's kind of summarize here, because that's what we're trying to work up to, is knowing what happens when we look at an equation, identifying the different transformations. For instance, yesterday we did right, left, up, and down. Today we're doing the reflecting. And it says that the function negative f of x is a reflection of f of x. Well, when the negative is in front of the function, that's going to flip our graph over the x-axis. When the negative is inside the function, it's going to reflect it over the y-axis. And I don't know if you heard me say, but I talked about outside and inside. But let's switch gears over here to our transformations chart and fill in the next two boxes. We filled in these in our last set of notes. So now we're on the next two. And once again, y equals negative f of x, or y equals negative in front of x squared. That means that we're going to reflect over the x-axis. And once again, the negative is in front of the function, so it's outside of the function. And for some of you, the outside and the inside is working, and for some of you, that's not working, so decide whether it works for you or not. Well, if we can reflect over the x, we can also reflect over the y. Over the y-axis. And that means f of negative x. So the negative is on the inside of the function. So filling in that chart there hopefully will be an excellent study tool as we get closer to the test. Flipping the paper over now, our real notes, not the transformations table. What we're going to do is we're going to state the vertex of each of the following parabolas, then list the transformations that have occurred in each of the following quadratic expressions, and we're going to sketch a graph. Well, remember the vertex. That's what we really spent our time on yesterday, was the turning point, also known as the vertex. And in this particular problem here, we're going to change the sign and keep the sign. Change the sign on the group. Keep the sign. There's our turning point. That's our vertex. Which ultimately, when we were doing these types of problems yesterday, ultimately means that we're going to go left 3. Gotta spell it right. Left 3. Left 3. And the minus 1 means down 1. But we have one more transformation on this. And it actually is the negative in front of the function. Because it's in front of the function, it's outside of the function. And that's going to be the reflect over the x-axis. Now in this particular case, when I draw the graph, I'm going to make 2 on here. So you might want to wait until the end to get it drawn. You could also type this equation into your calculator if you have it and look at your points on your calculator. But realistically, when we're doing this, the first transformation that's listed in this problem comes from that negative. So when we draw our picture here, we really want to reflect it first. So to reflect it, what happens is it would be the 0, 0. And then remember, that's going to turn us upside down. So we're going to go 1 to the right and 1 down, 1 to the left and 1 down, 2 to the right and 4 down, 2 to the left and 4 down. That's the reflection. But we have more than that now. We've got our other transformations that we've talked about. So that's just the reflection. But now that we've got the reflection, let's move that graph left 3 and down 1. So moving our vertex, left 3 spaces, down 1. And that means that all of the points on our quadratic are going to move left 3 and down 1. 1, 2, 3, down 1. 1, 2, 3, down 1. 1, 2, 3, down 1. And 1, 2, 3, down 1. And really this pinkish purple color graph is the picture of our reflected left 3 down 1 graph. That's really the one that we want. So if you only want to have one on your screen, just draw that pinkish purplish colored graph. If you've got a graphing calculator, it's helpful. You can type it in and get your points rather easily, I hope. But we still need to be able to identify what's happening from our equation. And this one yesterday gave us some particular trouble when we were trying to identify the vertex. And for those of you who have a calculator, let me recommend that if you don't know what the vertex is when you're working with these problems, then why not type in the, oh my gosh, why not type in the equation try that again, and see if we can identify the vertex from there. And that is parentheses, negative x squared, I need my other parentheses first, squared, plus 4. If we look at the picture, if we didn't know what the vertex slash turning point was, do we know what it is now? And hopefully the answer is yes. It is 0, 4. And we actually only have 2 transformations on this one. The first transformation comes from that negative that's inside the parentheses, which means that we're reflecting over the y-axis. The negative is inside the function. The other part is, it says plus 4. That's our up 4, our transformation. And we saw the picture here with the vertex, which we used to help. And once again, if you recognize the pattern, nothing much changed. We went 1 space to the right and 1 up. 2 spaces to the right and 4 up. We went 1 space to the left and 1 up. We went 2 spaces to the left and 4 up. And here's our picture. Now I know this question doesn't ask for it, but what's the domain of this quadratic? Well, the domain of that quadratic is negative infinity to infinity, which means all reals. And the other question that I've asked you beforehand is, what's the range? The range deals with the y values, and when we're looking at the range, we're asking ourselves, do we have a high point, do we have a low point on the graph? And in this case, we have a low point on the graph at 4. And our graph then is going to continue to go upward. So our range is going to be 4 to infinity. We were working with that in last week's work, and I don't want you to forget all about it as we are moving forward here. Y equals negative x squared plus 6. We want to know what the vertex is, so I'm going to pause here for 5 seconds. See if you can think to yourself, what is the vertex? Did you get 0, 6? And I'm hoping. And we have 2 transformations in this problem. The first one listed is the negative. Are we going to reflect over the x-axis or to the y-axis. And hopefully you were thinking x. The negative is in front of the x squared. So it's outside of the function. Plus 6 is also outside of the function, which means we're going to go up 6. If you do have a graphing calculator, you can just type that in and that might be able to help you. But remember, we're reflecting over the x, so we're going to turn this graph upside down. The pattern still stays the same. Instead of one space to the right and one up, we're going to go one space to the right and one down. Instead of going 2 spaces to the right and 4 up, we're going to go 2 spaces to the right and 4 down. Instead of going 1 space to the left and 1 up, we're going to go 1 space to the left and 1 down. And then we're going to go 2 spaces to the left and 4 down instead of 4 up. And do the best you can to make it not pointed. Mine's kind of pointed, but it's not supposed to be pointed. Again, it's not asking for this on the paper, but what's the domain of this function? And the domain of this function is all reals again. Our negative infinity to infinity. Our range is not. When we're looking at the range, we're looking at the y values. And we ask ourselves, do we have a high point or do we have a low point on the graph? And in this particular case, we have a high point on the graph. It's at 6, and then everything is below that. And when we write this in interval notation, it's going to be negative infinity to 6. Infinities always have a parenthesis. The 6 is on the graph, so we need that bracket. Again, graphing calculator can be helpful to you. But to finish here, sometimes reflections are necessary after a graph has already been translated. So in the picture to the left and the picture to the right, they are the same picture. And what we want to start with is we want to start with what's the vertex form of this graph? Well, as we look at this, first thing that we need to identify is what is our turning point on this graph. And our turning point looks like it's negative 2, 1, 2, 3, 4, 5, 6. Negative 2, 6. The other thing to notice is that it's flipped over. So when we start this, it's going to be f of x, or if you prefer to write y, equals. Well, it's flipped over the x-axis. So we're going to put the negative out in front. Now, this is going to be something squared. Is it going to be minus 2 or is it going to be plus 2? It's going to be plus because remember, we changed the sign. We changed the sign to get the negative 2. And then the outside sign stays the same. So there's the vertex form of the given quadratic. And now what we want to do is we want to, in part A, sketch the graph of the function reflected over the x-axis. So this one's going to be over the x-axis. And I just write that down to keep track of what we're doing. So what I'm doing, I'm going to start with the turning point of negative 2, 6. This point here is going to reflect over the x-axis. It's 6 spaces above the x-axis. So now it's going to be 1, 2, 3, 4, 5, 6 spaces below the x-axis. We're on the next point. looking at the point negative 1, 5. Well, it's 5 spaces above the x-axis, so we're going to go 5 spaces below. 0, 2 is going to become 0, negative 2. 1, negative 3 is going to become 1, 3. You probably see the pattern. We're flipping this graph over, as we say, and flipping it over is reflecting. So negative 3, 5 becomes negative 3, negative 5. And negative 4, 2 becomes negative 4, negative 2. And negative 1, 2, 3, 4, 5, negative 5, negative 3 becomes negative 5, positive 3. There we get our picture of a graph that's already transformed. We've moved it to the left and up. But what's our new vertex? Well, it's negative 2, negative 6. When we come over here to the right of that problem, this time we're going to reflect over the y-axis. That's what our directions say. Part B, the graph of f of x reflected over the y. So now what we're doing is we're looking at it and flipping it over the y-axis. So starting with the vertex here, instead of there, I'm going to flip it over. It was negative 2, 6. Now it's going to become positive 2, 6. That vertex is 2 spaces away from the y-axis on the left, so it's going to be 2 spaces away from the y-axis on the right. Our point 1, 5, negative 1, 5 is going to become positive 1, 5. 1 space away from the y-axis on the other side. Our point 0, 2 is going to stay 0, 2. And our point 1, negative 3 is going to become, let's see, I got to look at it again. 1, negative 3 is going to become negative 1, negative 3. And we can keep coming. This point 1, 2, 3, 5, negative 3, 5, well, it's 3 spaces away from the y-axis, so we're going to go 3 spaces on the other side. And this point here is 4 spaces away from the y-axis. So 1, 2, 3, 4 spaces away on the other side. And finally here, this point of 5, negative 3 is going to be, it's 5 spaces away from the y-axis, so it's going to be 5 spaces away from the y-axis on the other side. And here we get our quadratic reflected over the y-axis. And our vertex is 2, 6 this time.